Okay, so this is my first video of this kind, and I'm not sure what I'm doing, but I'm going to try a motion problem. Um, so we have a fitness test, 60-meter dash, and it must be run in under 8 seconds. We speed up at a constant rate of 4 meters per second squared for 2 seconds, and then we continue at that speed for the remainder of the race, and we want to know if we will pass. So there's two parts, two different types of motion going on. They're both constant acceleration. Initially, you have an acceleration of 4 meters per second squared, and then you have an acceleration of 0 meters per second squared. Um, so there's multiple ways to do this problem. I guess the two that come to mind will be seeing how far you run in 8 seconds and then seeing if it's greater or less than 60 meters. And the second would be see how long it takes you to run 60 meters and then seeing if that's greater than or less than 8 seconds. I'm going to go with the first one, and I'm going to calculate how how far I run in 8 seconds and compare it to 60 meters. So there's two parts of the motion. We're going to start out by drawing this motion diagram, actually. So for the first 2 seconds, the dots are going to be getting farther apart. We'll label that there, 2 seconds. And then the dots are going to be evenly spaced for the remaining 6 seconds. So we'll go 8 seconds. So this is going to be our 0 seconds, x initial. We're going to call it x1, x2, x3. Velocity 1, velocity 2, velocity 3, and we have accelerations as well, but I'm not going to write that stuff in there. So let's find how far we travel in our first 2 seconds. So we're going to be using the second equation here for position. So we're going to go x2 equals x initial, which is 0 meters, plus initial velocity, and it's 2 seconds, but of course that won't really matter. And then we're going to have 1/2. The acceleration is 4 meters per second squared times 2 seconds that we're accelerating for squared. Okay, so now we can solve this. So 2 squared is 4, times 4 is 16, 1/2 of that. So we got 8 meters. So now we know that our x2 is 8 meters. So let's find our second velocity, and we can use this first equation there. So we're going to do v2 equals v1 plus a delta t. So v1 is 0 meters per second plus 4.0 meters per second squared times 2 seconds. So we have 8 meters per second. So now let's find our final position. So it's going to be x3, and we're going to say our initial position. We're gonna solve this part considering x2 as our initial position. So this will give us our final position altogether, and we won't have to do any adding at the end. So, and then our v2 is 8 meters per second, and we're going to be doing that for 6 seconds. And then we're going to have 1/2 acceleration is now 0 meters per second squared, and 6 seconds squared. So this we know is 0. And so 6 times 8 is 48. And units cancel. It's good. So 8 meters plus 48 meters is going to give us 56 meters, which of course is less than 60 meters. So we fail the fitness test. Okay, now we want to draw our graphs, and I think it's easier to start with the velocity graph in this case. So we're going to have a VT graph, and we're going to have 2 seconds. So for the first 2 seconds, our velocity is going to be increasing with a constant acceleration, so we have a constant slope. At 2 seconds, we no longer increase, and our slope goes to 0, so that should be a horizontal line there. All right, and then now we want to do our acceleration graph. So we have a t, and so for the first 2 seconds, we have a constant acceleration at 4 meters per second squared, and then at 2 seconds, we drop down to an acceleration of 0 meters per second squared. And finally, we're going to do our xt graph. And we're going to have 2, and we'll say 8 meters. So we're going to be going from this to this, and we're doing it with an upward concave slope. And then from there on out, we want to show clearly that this now becomes a straight line. It's a crappy drawing. But now that our acceleration is 0, we have a constant velocity, and we have a straight linear slope on our position graph. So that should be everything. And I hope this is helpful.